Good morning, students. Today your topic is to finding the solution of given algebraic equation or transcendental equation. The first method is completed by section method. The second method is Newton-Raphson method or method of tangents or Newton iterative method. In this method, how to finding the root of the given equation. See that first of all procedure in this method. Consider an equation f of x is equal to 0. So in this method, the given formula is given for finding the approximation roots. That is equal to here xn is equal to xn minus 1 f of xn minus 1 by f dash of xn minus 1, where n is equal to 1, 2, 3 up to so on. And xn is equal to n is equal to 1 first approximation roots. N is equal to substitute second approximation up to so on. We have to finding the more approximations and which approximation is satisfy the given equation, that is a required root. Otherwise any two consecutive roots are equal, that is a required root. Using this formula is called a Newton-Raphson formula, that is approximation value. First finding n is equal to 1, substitute, we getting the first approximation. So that is equal to x1 is equal to x0. x0 is the initial value, and if the given in the question initial value, or otherwise we finding the x0. So how to find the x0, we will see then the example. So that is x1 is equal to x0 minus f of x0, substituting in the x0, next to f dash of x0, and finding here f of x, finding f dash of x, find out. Substituting here we getting the first approximation. That is x1 is first approximation to the root, and which is better approximation than x0. If x1 substituting in the given equation, if satisfied, that is f of x1 is equal to 0, then x1 is the required root. Otherwise we have to finding the second approximation, that is equal to, the second approximation is x2 is equal to x1. x1 is equal first finding the approximation here. Using first approximation you have to finding the second approximation. So this is x2 is equal to x1 minus f of x1 by f dash of x1. So if f of x2 is equal to 0, then x2 is a required root. Otherwise we have to finding third approximation. So up to procedure is continue. Any root is satisfy the given equation, that is a required root. Otherwise any two consecutive roots are equal, nearly equal, that is a required root. This is a Newton-Raphson method. So that is a so here note, if initial approximation x0 is not given in the problem, then let x0 is equal to a or x0 is equal to b, and ab is the, we have to finding the interval here first of all. If not given interval, we have to finding the interval a comma b, such that f of a and f of b have opposite signs. So which value a and b are near to 0, and after substituting f of a or f of b that is near to 0, that is a or b is the initial value. So that is choosing the x0 value if not given in the question. So this is the procedure. See the example here. So find the real root of the equation x cube minus 2x minus 5 is equal to 0. Correct 3 decimal places by Newton-Raphson method, and finding the root up to 3 decimal places we have to finding. So that is equal, let f of x is equal to assumption given x cube minus 2x minus 5 is equal to 0. Next finding f dash of x. F dash of x is equal to 3x square minus 2. So there is no given interval, we have to finding the interval a comma b, such that f of a and f of b have opposite sign. First substituting 0. So f of 0 is equal value 0 cube minus 2 into 0 minus 5 is equal to minus 5. So negative. Next finding f of 1. So f of 1 is equal to 1 cube minus 2 minus 5 is equal minus 6. This is also negative. And there is no roots between 0 and 1. Next one, f of 2. f of 2 is equal to also minus 1 and this is also negative. And there is no roots 1 and 2. Next f of 2.5. So f of 2.5 we are getting 2.5 whole cube minus 2 into 2.5 minus 5 is equal to 5 into 6 to 5. This is a positive and chudandi. Consecutive value is positive negative. Because the f of 2 negative, f of 2.5 is a positive. So therefore the root lies between 2 and 2.5. Okay now. So that is equal, the root is lies between 2 and 2.5. Okay, now choosing the initial approximation. So initial approximation value is f of 2 or f of 2.5 is near to 0. Which one is near to 0? F of 2 is equal to minus 1. Minus 1 is near to 0. So therefore x naught is equal to 2. So f of 2 is equal minus 1 is near to 0, then let initial approximation x naught is equal to 2. Okay, next to finding first approximation by using the Newton's formula. So by Newton's-Raphson formula is, this is a Newton's-Raphson formula, xn is equal to xn minus 1 minus f of xn minus 1 by f dash of xn minus 1. Okay, first substituting n is equal to 1. Okay, now the first approximation. So put n is equal to 1, the first approximation root x1 is equal to x naught minus f of x naught by f dash of x naught. X naught is equal to 2 together. That is equal to 2 minus f of 2 by f dash of 2. So 2 minus, so f of 2 means given f of x here, f of x load 2 substitute, we are getting the value minus 1. F dash of 2 means already finding f dash of 2, substituting 2 we are getting the 10. So that is equal to x1 is equal to 2.1, the first approximation. Substituting the second approximation to the root is x2 is equal to x1 minus f of x1 by f dash of x1. We have to finding up to 3 decimal places here. Only 1 decimal place is getting. So next to finding second approximation, that is x2 is equal to x1 minus f of x1 by f dash of x1. x1 is equal to choosing 2.1. So 2.1 minus f of 2.1 by f dash of 2.1. Substituting in the given equation 2.1. So f of 2.1 finding 0.061, f dash of 2.1 11.23. So simplification, x2 is equal to 2.0945681. So here not equal, only 2.1 2.0 kada. So one decimal place not equal. Okay, next approximation, third approximation we have to finding x3 is equal to x2 minus f of x2 by f dash of x2. Okay now, using x2 is equal to this value. So that is equal to 2.0945681 minus f of 2.0945681 by f dash of 2.0945681. So substituting in the given equation we getting the value, this value, this is the f dash of x2, this is f dash of 2. Okay, that is equal to 2.0945514. So observing here x2 approximation, x3 approximation nearly same chudandi. Up to 4 decimal places, 0945 0945. In the question only up to 3 decimal places here. 4 decimal places also equal. So this is a required root. So second, third approximation are same up to 4 decimal places. Okay, therefore hence x is equal to x3 2.0945514. This is a required root, that is approximationally. Okay, this is a Newton-Raphson method. Okay, see the next example. Okay, find the real root of x plus log x base 10 minus 2 is equal to 0 near to 1.8 by Newton-Raphson method. So that is equal to already given x naught value kada, near another, and that is the initial value is 1.8. Okay now, so is not required to finding the interval, directly using the Lagrange's formula, Newton-Raphson formula only. Okay now, ఎందుకంటే ఇక్కడ ఇంటర్వెల్ ఫైండ్ అవుట్ చేయాల్సిన అవసరం లేదు, ఆల్రెడీ గివెన్ ఇనిషియల్ వాల్యూ 1.8. సో దట్ ఈస్ ఈక్వల్ టు గివెన్ f of x and f dash of x. So initial value is x naught is equal to 1.8. Okay na? So by Newton-Raphson formula, this is a xn is equal to xn minus 1 f of xn minus 1 by f dash of xn minus 1. First approximation, so that is equal to x1 is equal to x naught minus f of x naught by f dash of x naught. That is equal 1.8 minus f of 1.8 by f dash of 1.8. Substituting the given equation, we getting the value 1.8 minus 0.0355533 by f dash of 1.8 1.5555. Simplification 1.76446. This is the first approximation. Okay, so next second approximation. This is the second approximation. X2 is equal to x1 minus f of x1 by f dash of x1. That is 1.76446 f of 1.76446 by f dash of 1.76446. Substituting the given equation, we getting the value. So that is equal to required value getting x2. x2 is equal to 1.75739. So next third approximation, x3. x3 is equal to x2 minus f of x2 by f dash of x2. Okay, that is equal to substituting x2 value, we getting simplification, we getting the value is, after simplification, 1.75595. Okay na? So see that second third approximation are same, nearly two decimal places same andi, 1.75 1.75. So this is also near to 1.8 kada. So therefore the required root is 1.7559y, that is approximately. So this is a Newton-Raphson method. Okay, okay, next example, see that find the real root of x cube plus x plus 1 is equal 0 up to 3 decimal places. So observing the given equation, first of all x cube plus x plus 1 is equal 0 ante here finding the real root kada, positive root or negative root, but any positive root is not satisfied x. X substituting any positive value not satisfied. Okay na? That is must be finding the negative root. So that is equal to here finding the negative root. F of x is equal to x cube plus x plus 1 is equal 0 and f dash of x is equal to 3x square plus 1. So first assumption, finding the interval, the first is substituting 0. F of 0 is equal to 1. Negative value కదా మనకు కావాల్సింది, కాబట్టి ఇప్పుడు choosing the value 0 minus 0.5 minus 1 minus 1.5 minus 2 up to so on. That is the negative value, we have to finding the negative root. So that is f of minus 0.5 substituting getting 0.375. This is also positive only. So the root is not lies between 0 and minus 0.5. Next one, minus 1. So minus 1 is equal to here minus 1, negative value only. So before value is a positive kada. The f of minus 0.5 is positive, f of minus 1 is a negative. So the root is lies between minus 0.5 and minus 1. Avuna? That is minus 1 and minus 0.5. The root is lies between. So which value is near to 0? So f of minus 0.5 is equal to 0.375 is near to 0 kada. Therefore initial value is x naught is equal to minus 0.5. So therefore x naught is equal to minus 0.5. So by Newton-Raphson formula, this is the Newton-Raphson formula, finding the remaining approximation roots. First x1 first approximation, x naught minus f of x naught by f dash of x naught, that is equal to minus 0.5 minus of f of minus 0.5 f dash of minus 0.5. Okay na? After simplification is, we getting the value is x1 is equal first approximation minus 0.71428. Okay, remaining we have to finding the next approximation. Second approximation is x1, first approximation choosing, that is equal to x1 substituting here f of x1 by f dash of x1. So simplification is x2 is equal to minus 0.683179. Next, third approximation is x3 is equal to x2 minus f of x2 by f dash of x2. So that is equal to x2 substituting here after simplification, x3 is equal to minus 0.6823286. Okay, next approximation, fourth approximation, x4 is equal to x3 minus f of x3 by f dash of x3. Substituting x3 value, that is equal to simplification, x4 is equal to minus 0.682328. ఇక్కడ చూడండి, x3 and x4 approximation nearly same up to 5 decimal places. 6 decimal places also equal. So this is a near same. So this is a required rule. Third, fourth are equal approximations. So therefore, hence required root is x is equal to x4 minus 0.6823281. Okay, na? This is a Newton-Raphson. So see the next example. Find the Newton-Raphson formula to find the reciprocal of a positive number. Hence find 1 by 18. So reciprocal of a positive number means 1 by n. For example, x is any positive number, then we have to finding is 1 by x. So how to finding the formula for Newton-Raphson formula? See that here important question. So let x is equal to 1 by k. X is equal to 1 by k is the reciprocal of a positive number k. K is belongs to r plus. Okay. So x is equal to 1 by k is the reciprocal of a positive number k. So that is equal to 1 by x is minus k is equal to 0. Wait, outside reciprocal 1 by x. Right, outside k, that is 1 by x minus k is equal to 0. So therefore this is a required function f of x. This is a equation only. So that is let f of x is equal to 1 by x minus k is equal to 0. Okay, f dash of x is equal to here minus 1 by x square, k is 0. So this is f dash of x. So by using Newton-Raphson formula, so xn is equal to xn minus 1 minus f of xn minus 1 by f dash of xn minus 1. So that is equal substituting xn minus 1. So f of xn minus 1 means f of x is equal to here 1 by x minus k kada. So x place lo xn minus 1 substituting. So that is 1 by xn minus 1 minus k by. So this is f dash of xn minus 1. F dash x is equal to minus 1 by x square. And x place lo xn minus 1. That is equal to minus 1 by xn minus 1 whole square. Okay, na? So this is a simplification. So after simplification is take the LCM and cancellation. Xn minus 1 is the minus into minus plus. Right, the numerator. This is one of the term is cancel. Xn minus 1 whole square, one term is cancel. That plus xn minus 1, ikkada minus plus into minus minus k into here xn minus 1 whole square. So that is equal to xn is equal to xn minus 1. This is a 2xn minus 1 here. Xn minus 1 common, 2 minus xn minus 1 common, that is k into xn minus 1. This is the required formula for finding the reciprocal of a positive number. Where substituting n is equal to 1, 2, 3 up to 7, we getting the approximation to finding the reciprocal of the a positive number. This is the Newton-Raphson formula for finding reciprocal of positive number. So now we have to finding 1 by 18. Using this formula we have to finding 1 by 18. So 1 by 18 means k is equal to here 18. So that is equal to reduce, let k is equal to 18, that is x is equal to 1 by 18. Okay na, that is equal to, let the initial approximation to the value 1 by 18 అంటే 1 by 18 కి nearly the perfect reciprocal of this number which value చెప్పండి. 1 by 18 కి reciprocal of near to perfect reciprocal. నియర్ టు 18 కి ఏముంది 1 by 20 కదా, అంటే 20 1 by 20 is equal to 0.5 అంటే 1 by 20 we have perfectly square root, sorry, positive reciprocal of perfect a positive number is 20 అంటే 1 by 20 1 by 20 is equal to here perfect reciprocal near to 1 by 18, therefore x naught is a 0.05. So this is the assumption and initial value near to 1 by 18 ki, so that is 1 by 20 is the perfect reciprocal, so x naught is equal to 0.05. So now using this formula, so that is equal, first substituting 1, x1 is equal to, from the equation 1 reciprocal formula of positive number by using Newton-Raphson formula. So x1 is n is equal 1, substituting x1 is equal to x naught into 2 minus k into 18 x naught, so that is equal x naught is equal 0.05 into 2 minus 18 into 0.5, that is equal to 0.055. Next to x2 approximation, x2 is equal to x1 into 2 minus 18 x1, so that is 0.055, 2 in minus 18 into 0.005, so that is 0.0555. Second approximation. Next third approximation you have to finding same, observing here all values same 0.0555 kada, so that is equal to, hence the required value is 1 by 18 is equal to 0.05555 approximation. So this is the to finding reciprocal of a positive number. Okay, is it clear? So next example, by using Newton-Raphson formula find square root of 6. So here root of 6 and finding, so that is equal to, let x is equal to root 6, therefore x square is equal to 6, write 6 inside, x square minus 6 is equal to 0. This is the, let the function f of x is equal to x square minus 6, so here f dash of x is equal to 2x. So by using Newton-Raphson formula, let initial approximation, let the initial approximation to the value root 6 and root 6 ki perfect square root near to 6. Cheppandi which one is the perfect square root to near 6 and root 4 or root 9 kada. Root 4 is equal to 2, root 9 is equal to 3 and perfect square root to near to 6 or 4 or 9, choosing any one. That is equal to assumption x naught is equal root 4, we are choosing, that is the initial value is 2, x naught is equal to 2. So by using Newton-Raphson formula we have to finding the approximation values. Okay now, first n is equal to 1, so n is equal to 1, x1 is equal to x naught minus f of x naught by f dash of x naught, x naught is equal substituting 2 minus f of 2 by f dash of 2, that is equal, we have to finding 2.5, first approximation. Next second approximation, so that is equal to here x2 is equal x1 minus f of x1 by f dash of x1, that is equal to 2.5 minus f of 2 by f dash of 2.5, we getting the 2.5. Okay na. Next third approximation, similarly same, x3 is equal to x2 minus f of x2 by f dash of x2, that is equal, we are getting after simplification 2.45147. Next fourth approximation, x4 is equal to x3 minus f of x3 by f dash of x3, after simplification we have to getting 2.44949. Next fifth approximation, x5 is equal to x4 minus f of x4 by f dash of x4, that is equal, after simplification 2.44948. Observing here nearly same 4 decimal places, chudandi, fourth approximation, fifth approximation nearly same, so that is the required value is x is equal to root 6 is equal to 2.44948. This is the required square root of this 6, that is approximation value, by using Newton-Raphson method. Okay, understood? Yeah, thank you. For more videos, please do subscribe my channel, like and share it. Thank you.